In this video, I'd like to talk about the math question of the day for Saturday, April 29th, 2023. And with this problem, we need to evaluate the limit, if it exists, of this expression here as x approaches -5. And the topic of limits is typically taught at the very beginning of Calculus 1. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And with limits, the first thing that we can always try is just plugging in the number, since sometimes limits are very straightforward, though often they can be quite challenging. So if we plug in -5, we're just setting x equal to -5 here, then we would get -5 squared, which is 25 minus 25. And in the denominator, we are again squaring -5, which is 25. Then we have plus 2 times -5, or minus 10, and subtracting 15 from that. But notice that in the numerator, we get 0, and in the denominator, we also get 0. Now, if you end up with 0 divided by 0, this is what's called an indeterminate expression. We can't really make sense of what's going on. There are several of these indeterminates, but at this point, there are two different approaches we can take. We can manipulate this algebraically and see if we can make some type of simplification. Or when you end up with these indeterminate forms, we can use what's called L'Hopital's rule, where we take the derivative of the numerator and the derivative of the denominator, and hopefully after doing that we can actually then evaluate the limit. So let's try to first manipulate this algebraically. We can notice that both the numerator and denominator are factorable. The numerator we can rewrite as x squared minus 5 squared to recognize that this is a difference of two squares. And a difference of two squares you can always factor as the first one minus the second one, ignoring the squares, multiplied by the first one plus the second one. And for our denominator, we can factor this into a product of two binomials, where the first term in each is x, since the coefficient on x squared is 1, x times x is just x squared. And these constant terms here would need to multiply to -15 and add to 2. And if we look through the factor pairs of -15, we can see that +5 and -3 would satisfy those conditions. They multiply to -15, but they add to +2. And of course, you can check either of these by just redistributing and making sure that you end up with what you started with. So at this point, let's plug in what we now know about our limit. We have the limit as x approaches -5 of our difference of two squares, which is x minus 5 multiplied by x plus 5, all divided by x plus 5 multiplied by x minus 3. And notice that this factor of x plus 5 is in the numerator and denominator, and we can cancel it out since something divided by itself is always 1. And once we do that, now we can actually evaluate this limit by just plugging in -5, since we will no longer end up with division by 0. So plugging in -5, we get -5 minus 5, which is -10. And in the denominator, -5 minus 3 would be -8. This would simplify to 10 over 8, positive 10 over positive 8, which simplifies to 5/4. So this should be our final answer here. And essentially what we have is a rational function which has a whole when x is equal to -5. It's not in the domain, it's not defined there if this was a function, but it's not an asymptote like an x value of +3 would be. When x is +3, we would have a vertical asymptote. But if we can make this cancellation, then we would just have a hole in the function where it wouldn't be defined. But if it was defined, it would have a y value of 5/4. Or another way to put that, which is maybe more accurate, is that the y value of the hole in our function is 5/4 when the x value of the hole is at -5. But like I mentioned, there is another way to evaluate this limit. So let me make just a bit more room. We can use L'Hopital's rule, which is usually just abbreviated as L'Hr. And we will just take the derivative of the top and the derivative of the denominator. And it depends when you will learn this. You will need to learn derivatives before you can use L'Hopital's rule. So if you're in the beginning of a calculus class, you probably haven't seen this yet. But it's fairly straightforward and we can check our work. If we take the derivative of the top, we just use the power rule. And we're still taking the limit as x approaches -5. But now we would just have 2x, which is the derivative of x squared. We bring the 2 down, we subtract the exponent by 1. And then the derivative of a constant is just 0. And for our denominator here, we again will bring the 2 down and subtract that exponent by 1. 2 minus 1 is just 1. And we'll do the same thing for the linear term. We bring the 1 down in front, and we subtract that exponent by 1. It becomes a 0, and x to the 0 power is just 1. So we have 2 times by 1, and the derivative of this constant here is just 0. So at this point, now we can try to plug in our -5 value for x. And when we do that, we would get 2 multiplied by -5, which is -10, divided by 2 multiplied by -5, which is -10, plus 2, which is -8. And of course, we know this simplifies to 5/4. So we get the exact same value, which is what we expected, but this is just a nice way to check our work.